2.5, Part 1. This is going to be the first 2 pages of 2.5. An nth degree polynomial can have at most n real zeros. If the complex number system, every nth degree has exactly n zeros. So what we've been talking about are the rational zeros and the real zeros. And we stopped at that. If you go back to your 2.3 notes, we stopped finding the zeros, just that they were real. Now that we've worked with complex numbers, we're going to start finding all of our zeros, and some of them are going to be possibly imaginary. So what this says, the fundamental theorem of algebra, is that there's going to be at least one zero. Neither of these theorems tell us how to find the zeros. They just say they exist. So looking at our examples, here I have x to the first power. That means there is only one zero. That's the only option. Here's 2 zeros, 3 zeros, 4 zeros. What we're going to be working towards is finding all of those zeros, whether they are real or whether they are complex. We're going to be finding all the zeros. Alright, so x minus 2, that one's pretty simple. Set it equal to 0. X is 2. It's real. It has exactly 1, and there it is. X squared minus 6x plus 9, we're able to factor that to x minus 3 and x minus 3. So we would say that it has 3 double root. There is one real zero that happens twice. It's a multiplicity of 2. X cubed, I can factor out an x, so I get x, and then I get x squared plus 4. Well, this can be factored, but not into difference of squares because this isn't a difference. So if it's a plus, it's actually imaginaries. So when we had x squared minus 4, we could factor to x minus 2 and x plus 2, because we could do difference of squares. Okay, but if it's addition of squares, it actually factors to imaginaries. So therefore, we get 0 and then plus minus 2i plus minus as all of our zeros. There's 3 of them, because that's what our power says. Only 1 is real, 2 are imaginaries. And if you're unsure about this factoring, you can always solve this. I could have said x squared plus 4 equal to 0. Then subtract the 4. When I square root both sides, I get 2 answers. And the square root of negative 4, well, the negative gives me the I, and the 4 gives me the 2. So if you're unsure of the factoring, you could always solve it. Okay, we know there's going to be 4 of them. This is a difference of 2 squares, so we can go x squared minus 1 and x squared plus 1. X squared minus 1 is still a difference of 2 squares, so it factors to x minus 1 and x plus 1. This is not a difference of 2 squares, but it is an addition of 2 squares, so that means I can factor it into the imaginaries, plus 1i and minus 1i, which is just I and I, so that my zeros are plus minus 1, plus and minus 1, and plus and minus I. Again, if you're unsure about that factoring, x squared plus 1 is 0, x squared is negative 1, and when I square root both sides, the square root of negative 1 is plus minus I. You could go through the solving method if you don't want, or don't understand, or don't quite feel comfortable with that factoring. But either way, we are finding all zeros. Alright, page 2 of part 1. Um, all the possible zeros are exactly what we did back a couple of sections, where we find all the factors of the constant and we put them over the factors of the leading coefficient. So in this case, here's my polynomial. I know all the possibles are the factors of the constant, so 1, 2, 4, and 8, and all the factors of the leading coefficient, so positive, negative, tells me positive, negative 1, 2, 4, and 8 are all the possible rational zeros. Now we're going to pull out our calculator. Put in that equation, x to the 5th, x cubed, 2x squared, 12x, and when I graph it on a normal screen, I see 1, and then that touches, so that's 2 and 3. So that's actually 3 real zeros, which implies I have 2 more imaginary. Alright, so what we're going to do is we're going to go through this process. Now, it looks like negative 2 is probably a 0, and it looks like 1 is the double root, or the multiplicity of 2, 0. So we're going to start with negative 2 and 1 as a possible double root, which might be is 1, and the reason for it is because it doesn't cross. It touches the x-axis, and that goes back again a couple of sections. If we have multiplicity that's even, it does not cross, it only touches. Alright, so let's just do a quick sketch of the picture that we have at negative 2 and 1. And we know the y-intercept is going to be 8 just because of that's what the constant is. It's odd, and the leading coefficient is positive, so I know it's going to end up but start down. This we think is a touch. So something like that, of which we already kind of graphed it, so we had an idea of what that is. Just keep in mind all of this stuff comes from what we learned a few sections back. Alright, so now we're going to go through our synthetic division, and we're going to prove this stuff. Alright, we believe 1, and I'm using 1 because it's easier to multiply by 1, is a factor. So the coefficients are 1, 0, because there's no fourth power, third power, second power, first power, constant, and the last, hopefully the remainder is going to come out to be a 0. Alright, so we're going to bring down and go through all of our synthetic multiplication process, and indeed it comes out to be a 0. Now, we believe 0 to be a double root, so we're going to do it again. Our solution, we're going to do it with 1 again, because we believe it happened twice. Again, the last position should be a 0, hopefully. First position comes down and go through our synthetic process. And indeed, it does come out to be a 0. The next one we believe is negative 2, so we're going to do it again. Again, hoping that our last position comes out to be a 0. First position comes down. And yes, that works. So all of these were true. What we guessed was true. But we have this leftover piece. We know x minus 1 happened twice, and then our plus 2 is a factor. Now the leftover is x squared plus 4, because that's our constant single squared term. So we know this gave us 1 as a double root, gave us negative 2. Now what does this give us? It should give us, hopefully we've done it a couple times now, you should be very clear that this is going to give us a plus minus 2i, because it's x minus 2i, x plus 2i, factoring version, or if you solve it, you're square rooting the 4 and you get plus minus 2i. So we knew we were going to have 5 zeros. Our picture told us that we're going to guess there's 3 real zeros. We tested the 3 real zeros and proved it, and then came up with the leftover that would give us the imaginary. So these are the factors, and these are the zeros. Be very clear as to what the questions are asking you, because they will ask you what are the factors and what are the zeros, and you need to make sure that you are answering appropriately. So pay attention to the directions and what it is that it is asking you to do. So that's part 1 of 2.5.